International Payline Group presents air induction system testing and problem diagnosis. This program will cover the pressure testing procedure of engine air induction systems. The program will discuss why the testing is to be done, at what time it should be done, and how to do the actual testing. A major cause of engine problems and failures is dirt. Loose clamps, cracks in the hoses or piping of the air induction system will allow dirt to enter the engine. In addition to servicing the air cleaner elements, there are other areas in the air induction system which must be maintained. Service Bulletin 12A7601 outlines the air induction pressure testing procedure. It should be in every mechanic's hands when he is involved in an engine problem. The entrance of dirt through the air induction system will cause scuffing of the rings and cylinder walls. Besides the scuffing of the rings and cylinder walls, wear will occur on the top side of the piston ring. Dirt will also cause heavy ring face wear. A good test on whether the chrome is worn from the ring is to wipe a solution of copper sulfate on the face of the ring. The areas where the chrome is worn off will turn a copper color. Today's diesel engine will consume approximately 60,000 cubic feet of air in 1 hour, or the air in a 10 by 10 room in 1 minute. Because this large volume of air moves through the engine air induction system must be carefully maintained. The engine can be damaged in a short period of time if unfiltered air is allowed to flow into the engine. The air inlet system generally is comprised of an air cleaner, hoses or tubes, and connecting fittings and clamps. The air inlet system is designed for a specific engine application. The air cleaner size is specific for the quantity of air that the engine will consume. It is efficient to filter the air in all environments to provide a minimum initial restriction and to achieve satisfactory element servicing intervals. The hoses and connections are designed to allow good airflow and to seal against leakage. On a turbocharged engine, the exhaust gases are used to drive the turbine wheel. The turbine wheel drives the impeller wheel through a common shaft, forcing air into the engine under pressure. Therefore, the air from the turbocharger to the engine is under pressure. Contaminated air may be the direct cause of compressor wheel failure. Air for a naturally aspirated engine is drawn into the cylinders as the pistons move up and down. All connections will be under a negative pressure. The air induction system is composed of an air cleaner assembly, intake pipe hoses, and clamps. All of these components will be under a negative pressure caused by the engine's requirement for air. As a result, atmospheric pressure will push air into an engine at any point there is an opening. Any connection in the intake system becomes a source for unfiltered air to enter the engine. The air moving through the air cleaner must be the only source of air to an engine. The air cleaner element seals and gaskets must always be in excellent condition. The hold-down nuts should never be over-tightened. Over-tightening will cause distortion in the main housing and the filter element, which would cause air to bypass the filter assembly. Before using any air cleaner element, inspect the seal. If the seal appears damaged, do not use that element. When an element is removed from a machine and the seal shows signs of sticking to the body, put in a new element. If this has occurred, you must be sure to remove any of the seal material from the air cleaner body. If this material is left, a new filter element may not seal. The damage shown here can be caused from poor handling or storage. This kind of damage can cause the metal mesh to cut minute holes in the paper element. Here's what happens when the air cleaner element is tapped against the track or tire. The outside metal mesh will cut the paper element. Here is a close-up of the element previously shown. There are 3 distinct holes in the element. If this element were to be put in a machine, the engine would be damaged in a few hours. The rest of this program will deal with the procedure for testing the air induction system and the tools necessary to perform the test. The equipment required to pressure test an engine air induction system consists of the following: a roll of duct tape, a paintbrush, liquid soap, a T-connector, 1/4-inch air hose with push-lock male pipe fittings and quick disconnect fittings, a screwdriver, a crescent wrench, a 0 to 15 psi gauge, and a flashlight. The tools should be stored in a steel toolbox so they are ready to go when needed. The remainder of the program will discuss the procedures for testing the suction and pressure side of the air induction system and the air cleaner indicator. One of the main areas of concern is the connections at the air cleaner, turbocharger, and the air compressor, if equipped. The procedures in the program are also applicable to a naturally aspirated engine. Here is shown the connections from the air cleaner to the intake manifold. The rest of the air induction system should also be tested. Remember, the air induction system on a naturally aspirated engine is always under a negative pressure or vacuum. It then becomes very important to have no leakage where the manifold mounts to the engine. The first step is to remove the air cleaner cover. Removing the cover exposes the main element. Check the nut to see if it is loose and make sure that the gasket is in place. Remove the main element and inspect the gasket for any damage. Removing the main element exposes the safety element. Check the tightness of the nut and whether the gasket is in place. At this point, remove the hold-down nut, gasket, and the safety element. Inspect the elements for damage, check the seals, and be sure they are completely bonded to the element. Check the sealing surface inside the air cleaner body. If there is any sign of damage to the air cleaner body, it should be replaced. Under no circumstances should the air cleaner body be cleaned by air pressure, because you will just blow dirt directly into the air induction system. Wipe out the air cleaner element sealing area using a damp rag. The first step in performing the air induction system check is to tape the safety element. We recommend duct tape because of its strength. Be sure the element is completely taped. The tape should overlap so there are no gaps where air leakage could occur. Install the taped element, gasket, and nut. Tighten the nut so that the element is sealed against the body. Remove the air cleaner indicator line and install the T-fitting for a 0 to 15 psi air gauge installation. Reinstall the air cleaner indicator line to the T-fitting. The air line and the test gauge can be hooked up different ways depending which is easier. The air pressure connection can be put in the intake manifold as shown, and the gauge would be connected to the T-fitting in the intake pipe. On other machines, it might be easier to connect the air pressure and the gauge to the T-fitting, leaving the air indicator line off to be reconnected later in the test procedure. With all connections in place, turn on the air supply and then turn the air regulator so there is a 3 psi reading on the air gauge of the pressure test kit. It is important that the pressure does not exceed 3 psi. Higher pressure will cause leakage on the suction side that would not occur when the engine is operating. In a container, mix the liquid soap with water so there's a lot of soap bubbles. Soaping the air induction system to check for leakage should be done in a systematic manner. Work from one end of the system to the opposite end. Here we are starting at the outlet of the air cleaner body and progressing down through the entire air induction system. If a leak is found at any point in the test, it should be corrected right away. Soap the entire air induction system, including the air piping, even though it is metal. There could be porosity in the pipe that would allow unfiltered air into the engine. If leakage does occur, the pipe must be replaced. Anytime a leak has been found in the air induction system and it has been corrected, be sure to test the area once more with a soap solution. If a leak is found at any point, it should be fixed. Tightening the hose clamp stopped the leak in this case. The connection from the piping to the turbocharger is next in line. On this machine, a leak was found at the turbo connection. Many failures of air compressors are directly related to contamination. If the machine is equipped with an air compressor, then it is next in line to be tested. Soap the connection at the intake pipe, the hose, and the connection at the air compressor. If any leaks are found, correct them and retest with the soap solution. The flange connection to the air compressor is the next area to test. This one was leaking, as noted by the bubbles. Tightening the flange connection corrected the problem. A V-type air compressor has 4 points which should be soaped at the compressor, 2 hose clamp connections, and 2 compression fittings. Repair all leaks. Even though the air supply for this compressor is on the pressure side, as on the 560, it still must be checked, because dirt will enter the compressor at any open point. Be sure the connection at the intercooler for the air compressor is tested with a soap solution. On some applications, it will be necessary to remove the hood to see the total air induction system. If you can't see it, you cannot do the test properly. The L175C and TD15C are 2 examples of applications where the hood must be removed. The arrows on the left are pointing to the connections that must be tested with the soap solution. The arrow on the right is pointing to the air cleaner indicator line. Remember, you must put a 0 to 15 psi gauge in this location to ensure that the inlet, suction, side of the air induction system is under 2 to 3 psi air pressure. Pressure testing is also necessary anytime any part of the air induction system is removed or replaced, such as when updating with the machined end air intake pipe, or when updating with the new ultra-tight hose clamps. The new hose clamps are wider and resist loosening from vibration. This is a side view of the TD25C application. As you can see, the hood does not require removal in order to perform an air induction system pressure test. When the engine is rapidly accelerated, there is a split second of time when the pressure side will have a negative pressure. Once the turbocharger catches up, the air induction system from the turbo to the engine will again be pressurized. In general, pressure side leakage is not detrimental to engine life. However, a severe leak may cause low intake manifold pressure. As a result, the leakage on the pressure side may be the cause of a power smoke complaint. The following procedure should be followed when checking the pressure side of the induction system. Shown on the left side are small bubbles from the turbocharger back plate area. On the right side are much larger bubbles. There is nothing wrong here. This is normal for this type of turbocharger. When there are large bubbles as shown, be sure that the back plate cap screws are tight. Shown on the left are small bubbles from the intercooler plate. On the right are much larger bubbles. There is nothing wrong here. This is normal for this type of intercooler. When there are large bubbles as shown, be sure that the cap screws are tight. Apply the soap solution to the connections and pipe from the turbocharger to the intake manifold. After finishing the testing of the air induction system, there is one more area to check, and that is the air cleaner indicator and its tubing and connections. Excessive air cleaner restriction causes low power and excessive smoke. It also causes turbocharger oil to leak past the compressor seal. This oil leakage can result in unnecessary turbocharger replacement when the actual problem is excessive air cleaner restriction. The excessive restriction may be the direct result of a malfunctioning or inoperative air cleaner indicator. It therefore becomes evident that the operation of the indicator should be tested. The first step is to push the reset button to move the red flag out of the indicator window. At the beginning of the program, a T was installed on the machine. If the air pressure was connected to the T, it should be removed. If air pressure was connected in the manifold, disconnect it and put in the plug. Connect the indicator line to the T. Move the plastic hose from the pressure gauge port on the test gauge kit to the vacuum port of the MagnaHelic water gauge. Be sure to vent the pressure side of the gauge. If you do not have the gauge kit, remove the 0 to 15 psi gauge and install a vacuum gauge in the T. A water manometer can also be used in place of a vacuum gauge. After hooking up the gauges, remove the air inlet cap. Move the test gauge kit in back of the air cleaner indicator so that the vacuum gauge and the indicator can be seen at the same time. Start the engine and operate it at high idle. Slowly block off the air inlet until the air cleaner indicator flag shows in the window. Note the reading on the gauge the instant that the red flag covers the indicator window. As shown, the vacuum gauge reads 24 inches of water. This indicator is working correctly. This indicator is designed to be in the red at 25 inches of water vacuum, plus or minus 2 inches. The operating range is dictated by the application. Other indicators would have a spec of 30 inches of water vacuum, plus or minus 2 inches. An indicator that is in the full red at 20 inches of water, for example, is signaling the customer to service the air cleaner more often than is needed and should be replaced. Excessive smoke with a low vacuum indicates the possibility of a plugged orifice or sintered fitting or a restriction in the line. A vacuum higher than the maximum specified would mean the indicator is faulty and should be replaced. As was discussed previously, a plugged orifice or sintered fitting can cause engine problems. Shown here are the location of these fittings. The fittings can be located at the air cleaner outlet or on the turbo inlet pipe. In either case, it will be where the air cleaner indicator line connects to the system. The Engine Diagnostic Manual and Product Information Bulletin 12A 7402A cover the servicing and modification of the sintered fitting. When is it recommended that these tests be performed? These tests should be made every 1,000 to 1,500 hours of use. Doing them regularly can save the customer much expense and downtime. Whenever an engine is to be removed for overhaul, pressure test the induction system before you remove the engine. This test could give you and the customer the reason for the engine failure. After the engine is rebuilt and installed, perform the air induction system test. You now know that the air induction system is sound and does not leak. In summary, this program draws attention to the fact that the air induction system should be pressure tested using specific tools. 1. Follow up every 1,000 to 1,500 hours. 2. Prior to engine teardown. 3. After engine rebuild. 4. Whenever any part of the air induction system is removed or replaced. Attention was also given to the air compressor, the need to relate to the total system, air cleaner through intake manifold on a naturally aspirated engine, the fact that no leakage is permitted on the suction side, and the importance of checking the air cleaner restriction indicator was brought out with attention given to a plugged orifice or sintered fitting. This slide shows that the air induction system pressure tests can be done on all types of machines. Contamination is not unique to crawler tractors, payloaders, on or off highway vehicles, or manufacturers. This concludes the program. We are sure that if the procedures outlined in this program are followed, there will be more machine availability for your customers.